Hello students, now today I'm going to start a new chapter, that is flow of liquids. This is chapter 15. Chapter 14 is not there in the syllabus, so you can exclude the chapter. Now in this chapter we'll study about different laws about liquids. Okay, first topic in this chapter is ideal liquid. An ideal liquid is one which has the following two properties. First one is zero compressibility. That is, an ideal liquid is incompressible, that is, on pressing the liquid there is no change in its volume or either density. Most of the liquids may be considered approximately incompressible because on pressing them the change in their volume is negligible. For example, on pressing water by 1 atmospheric pressure, its volume changes only by a fraction of, I write it over here, a fraction of 0.000048. So this much is the change in the volume of water. Second property is zero viscosity. An ideal liquid is non-viscous, that is, when there is a relative motion between different layers of liquid, then there is no frictional force in between the layer. In actual practice, however, there is some viscosity in all liquids. It is less in gases but larger in liquid. So gases, the viscosity is less than in the liquids. So this two property, if there is zero compressibility and zero viscosity, the liquid is called as ideal liquid. The next topic is streamlined flow. Now when a liquid flows such that each particle passing a certain point follows the same path as the preceding particle which passed the same point, the flow is said to be streamlined and the path is called a streamline. The tangent drawn at any point on the streamline gives the direction of the velocity of the light at that point. Clearly, two streamlines cannot intersect each other. If they would do so, then there would be two directions of velocity of liquid at a point of intersection, which is impossible. The important property of a streamline is that the velocity of a liquid can be different at different points of a streamline, but at a particular point the velocity remains same. Now in this diagram over here, ABC are 3 points on the same streamline of the flowing liquid. So ABC is the path of the liquid. All these particles of the liquid which passes through point A also passes through point B and C. So the particles over here and over here are same. So same point passes from A to B to C. The velocity, the direction velocity is a vector quantity, so it has direction as well. So to find the direction, we draw a tangent. So this V1 gives the direction of velocity at point A, V2 at point B and V3 at point C. But at one and the same point, such as A, the velocity is always V1, whichever be the particle of the liquid at this point. The same is true for B and C also. Now let us talk about streamlined tube. If we imagine a tube made up of number of streamlines, okay, in the previous diagram, if the same type of line are made more and more, then what we get is a streamlined tube. Then this imaginary tube is called streamlined tube. So in this diagram, XY is a streamlined tube. The boundary wall of the streamlined tube are everywhere parallel to the direction of flow of the liquid. So this arrow shows the flow of the liquid. Therefore, the liquid can neither go out or come in through the walls of the tube. The liquid that enters at one end X leaves at the other end Y, as if it were flowing through the actual tube. So this is an imaginary kind of a tube where the liquid flows in this particular direction from X to Y, running parallel running in parallel layers. So every liquid particles passing from X will pass from Y. So such type of imaginary tube is known as streamlined tube. Okay, next is turbulent flow. In this type of flow, the particles of the liquid follow independent paths, and as such, intermingling of two or more layers takes place. In this case, the velocity of the particle at a point is time dependent and the velocity gradient is not constant. That means velocity gradient means change in velocity is not constant. So this is opposite of streamlined tube. Over here, the liquid can flow in any particular direction and it is not necessary that the same particle of the liquid flows through the same path. So this is opposite of streamlined tube. With this, we'll talk about critical velocity of the liquid and Reynolds number. Now, critical velocity is actually a barrier between streamlined and turbulent flow. So, I'll explain you this. When a liquid flows in a tube, the viscous force opposes the flow of the liquid. Hence, the pressure difference is applied between the ends of the tube, which maintains the flow of the liquid. I'll show you the previous diagram, such in this case. Now, if there is a flow of pressure, if there is a difference of pressure at this point X and Y, then only the liquid will be able to flow. Such as, imagine a pipe which is horizontal to the surface of the earth. Then what we can see is the water will not flow from one point to another. But if there is a difference in its potential, then only the liquid will be able to flow. So, now coming back to the topic, when a liquid flows in a tube, the viscous force opposes the flow of the liquid. So, there is a viscous force between the layer of the liquid which opposes the flow of the liquid. Hence, a pressure difference is applied between the point X and Y between the ends of the tube which maintains the flow of the liquid. If all particles of the liquid passing through a particular point in the tube moving along the same path, the flow of the liquid is called streamlined flow. This occurs only when the velocity of the flow of the liquid is below a certain limiting value called critical velocity, which is denoted by V. Vc is the critical velocity. When the velocity of the flow exceeds the critical velocity, the flow is no longer streamlined but becomes turbulent. So, if the critical velocity is exceeded, then the flow is turbulent flow. So, Reynolds, a scientist, proved that critical velocity of a liquid flowing in the tube is given by this equation over here. There is no derivation, direct equation. So, Vc is the critical velocity, which is equals to K, known as Reynolds number, N, it is the viscosity of the liquid, D is the diameter, and this rho is the density of the liquid. Now, Reynolds number for water is 2000, where Reynolds number, this is K, is less than 2000 for the streamlined flow, which is between 1000 to 3000 for the flow if it is unstable, and if it is greater than 3000, the flow is turbulent. So, when the velocity of the flow of the liquid is less than the critical velocity, then the flow of a liquid is controlled by the viscosity. The density having no effect on it. But when the velocity of the flow is larger than the critical velocity, when the density is larger than this critical velocity, then the flow is mainly governed by the density, the effect of viscosity becoming less important. It is because of this reason when a volcano erupts, then the lava coming out of it flows speedily in spite of being very thick or of large viscosity. So this is all about Reynolds number, which is a number which indicates what kind of flow it's given by the particular type of a liquid. Now we'll talk about viscosity. This term I hope you have heard before. It is the property of a liquid of which it opposes the relative motion between the adjacent layer. Now, when a solid body slides over another solid body, the frictional force begins to act between them. This force opposes the relative motion of the bodies. Similarly, when the layers of liquid slides over another layer of same liquid, the frictional force acts between them, which opposes the relative motion between the layer. This force is called internal frictional force. So over here, there is a diagram. Okay, a liquid is flowing in a streamlined motion on a fixed horizontal surface AB. Okay, AB is a fixed horizontal plane. The layer of the liquid which is in contact with the surface is at rest. So AB is at zero velocity, which will be at rest. This will not move. This layer of liquid will not move. The length of the arrows represent the increasing velocity of the layer. So there is relative motion between adjacent layer of the liquid. Let us consider three layers A, B and C. Their velocity are in increasing order. The layer A tends to retard the layer B while tends to retard C. So A, B, C have got different velocities. Thus, each layer tends to increase the velocity of the layer below it. This means that in between any two layers of the liquid, force acts which try to destroy the relative motion between the layers. This force are called viscous force. If the flow of the liquid is to be maintained, an external force must be applied to overcome the dragging viscous force. In the absence of the external force, the viscous force would soon bring the liquid at rest. So the viscous force is something which opposes this flow of the liquid. Okay? If there is more and more viscous force, it is difficult for a liquid to flow. So the definition of viscosity is given over here. Next, the property of viscosity is seen in different liquids. First of all, it is first example is in a stirred liquid. In a stirred liquid, if you stir a liquid, it will come to a rest on account of viscosity. Like thicker liquids like honey, glycerin, etc. have a larger viscosity than thinner ones like water. Second one is funnels while pouring different liquids. When we pour honey or water separately, then what we can see is water comes out readily from the hole of the funnel, while honey takes enough time to do so. This is because honey is much more viscous than water. As honey tends to flow down under gravity, the relative motion between its layers is opposed strongly, so it is more viscous. A few more examples are water while walking inside the water, like particles of cloud while falling from the sky. All these are different examples of properties of viscosity. So I've given you the basic idea of this chapter, what we are going to study. The other important topics we'll discuss in the next class. So this much for today. We'll continue in the next class. Thank you.